Today's video is about graphing logarithmic functions. A logarithmic function is the inverse of an exponential function. So we're going to use our calculator and sketch the following graphs. The logarithmic function, you're going to notice, looks like this. And this exponential function is going to look like this. And the definition of an inverse says that if I reflect the graph over this 45-degree angle, this 45-degree line, that I will get its inverse. And if we copy the logarithmic equation back over here on the same graph, you'll see that that's true. So the log equation is the inverse of the exponential equation. This stuff down here says that because we can only graph base 10 logs, we'll have to use the inverse function. We're going to do one problem that way, but we're not going to use that for all of our work. So for example, this problem, f of x equals log base 2 of x. The exponential inverse of this function is f of x equals 2 to the x power. And those values would look like this. If we graph this on our calculator, so type it into y equals, or on Desmos, type it in there, we're going to find that we get -2, -1, 0, 1, 1, 2, 3, and I'm just showing you values that I would graph. So this would give us 0.25, 0.5, 1, 2, 4, and 8. All right, these are the values we would find if we typed this into the graphing calculator. So to do the inverse, which is the function we're looking for, log base 2 of x, all you do is switch the x and y values. So these become 0.25, 0.5, 1, 2, 4, and 8. And these become -2, -1, 0, 1, 2, 3. And this is what we are going to graph. So our first point is 0.25, -2. So we go right 0.25 and down 2. Then our second point is 0.5, -1. So we go right 0.5 and down 1. Then we have 1, 0. So right 1 and up or down 0. Right 2 up 1. Right 4 up 2. And finally right 8 up 3. And then we are going to draw our line. So this is our graph for log base 2 of x. So let's talk about the different characteristics. The domain for this one, in the last graphing that we did, our domain was all real numbers, but this is the inverse of those functions. This is the inverse of exponential functions. So our domain in this case is actually going to be x is greater than 0, because if you look here, here is where x equals 0, that's the y-axis, and all of our points are to the right of the y-axis. And our asymptote this time is vertical. It's never going to actually touch the y-axis. So our range for logarithmic functions is always going to be all real numbers. You're going to notice too that our end behavior is backwards. It gives us the y values, the f of x, and we have to tell it what x is doing. So this first one is saying that when y, or f of x, is going to positive infinity. So this says when the graph is going up, so when the graph is going up, is the x value going left or right, or is it approaching a specific number? In this case, it is going to the right, and that represents positive infinity when we talk about that x direction. Now, as f of x goes toward negative infinity, so as our function goes down, if we're looking at the left and right of it, this function is It's not going to the right, it's kind of going to the left, but it's never going to cross the y-axis. So it's really getting close to 0. Our x-intercept is where it crosses the x-axis, so that means that the y value will always be 0. In this case, it is at 1. Finally, our asymptote is at x equals 0. And we're only going to do one more of these. And what I want us to do here is to type this function into our calculator into y equals. So y equals is this top left gray button. And then we're going to type in our function. So anytime that you have this +1, anything outside over here of the logarithm, we're going to have to use quite a few parentheses. So we're going to start with parentheses, and we're going to do log of x minus 2. So remember we did the change of base formula last week, or in the last lesson, to be able to convert logarithms so that we could type them in the calculator. So log base 5 of x minus 2 is the same as log of x minus 2 divided by log of 5. So that's what we're doing right now, is typing in log 5 end parenthesis, and then an extra parenthesis on the end because we had that extra one in the front to show that this is all one value. So our logarithm, we typed it all in and put it all in parentheses to show that it's one value. Then we are going to do +1 on the end. Finally, we're ready to hit graph, which is right here. When we do that, you're going to see that this part of the graph kind of disappears. It's not there. That is just a fluke on our graphs, on our graphing calculators. That is actually not the case. That value does extend, or that graph does extend beyond that, just like they have in this unit. Then we're going to hit second and graph to get to the table. You're going to notice that on the logarithmic functions, there are errors. So you're going to start where the errors stop. So we have the point 3, 1. And that's where we're going to put our first point. So right 3, up 1. Then we have the next easy point to plot is 7, 2. So we go right 7 and up 2. And that's really it. Everything else is a weird number. So we're going to go back to the picture of our graph and look at it to draw the line into our graph. All right, so take another look at your graph, remembering that this line is going to continue downward. All right, so what is helpful to notice is what our asymptote is going to be. And your asymptote in this one, remember that in the exponential ones, if we had a k value on the end, so we had, 2 to the x plus 7, this plus 7 would be what our asymptote was. Well, in exponential or in logarithmic functions, our asymptote is the opposite of this number. So that is a -2. Our asymptote is going to be x equals +2. And sometimes it is helpful to go in and put that line in there we go. Okay, so put that line in so that we know where our asymptote is and where that way we don't draw our graph incorrectly. So our graph is going to go like this. All right, so once that's drawn on there, let's go ahead and answer our questions here. Our domain always follows our asymptote. So since our asymptote is x equals 2, our domain is going to have an x and a 2, and if it's to the right of the asymptote, it's going to be greater than. If it's to the left, it will be less than. The range is always going to be all real numbers. Then our end behavior, we just have to look. So this one wants to know when the graph is going up, which way is it going? So the upper end of our graph is pointing to the right. That means positive infinity. The lower part of our graph is going toward our asymptote, and our asymptote is at 2. And finally, our x-intercept is where y equals 0. And if you recall, we actually did not plot that point because it's not a perfect point. So in the case that you do not have a perfect place where y equals 0, what we can do is we can make y equals 0 in our equation and then solve our equation. So I want to subtract 1 from each side. So I've got -1 equals log base 5 of x minus 2. Then if I convert to exponential form, this says 5 to the -1 power equals x minus 2. So then if I type 5 to the -1 power in my calculator, I'm going to get 1/5 equals x minus 2. Then I'm going to add 2 to both sides and get that 2.2 is equal to x. You may have also gotten 11 over 5, but 2.2 is easier to graph. So our x-intercept is going to be 2.2, 0. All right, that is all for today's video. Thank you guys so much for watching, and I hope you have a fantastic day.